Hello, today we're dealing with rational exponents. What is the solution of the equation? So if we have, let's see here, part A, and for part A we have 256 raised to the x plus 2 power, and that's equal to 4 raised to the 3x plus 9 power. How can we set these equal to each other? So first I can take 256 and think, okay, what number squared gives me 256? Now ultimately I can get this 256 down to 4, but it's going to happen in multiple steps. So what number squared will give me 256? And that number is actually going to be 16. So 16 squared will give me 256. And remember, this is being raised to the x plus 2 power. So really I have 16 squared, and that's being raised to the x plus 2 power. So in essence, I would distribute the 2 through. But I'm not done. I want to get to 4. So what number squared gives me 16? And that number squared will be actually 4. So 4 squared gives me 16. And so 2 times everything else here. So I have 2 times 2 times x plus 2. And so 2 times 2 is 4. So I have 4 raised to the 4 times x plus 2 power. And I can go ahead and distribute the 4 through to each term. So 4 times x is 4x, so I have 4 raised to the 4x, and I have 4 times 2, which is 8. So I have 4 raised to the 4x power, and that is set equal to 4 raised to the 3x plus 9 power. And since I have the same bases now, and that's what we wanted, we needed same bases. And when we have same bases, I can go ahead and set their powers equal to each other. So 4x plus 8 equals to 3x plus 9. So 4x plus 8 equals 3x plus 9. Let's go ahead and solve for x. So I'm going to subtract 3x on both sides of my equal sign. This cancels out. 4x minus 3x is just 1x, or just x plus 8 equals 9. And how do I solve for x? I'm going to subtract 8 on both sides. And 8 minus 8 cancels out, and I have x equals 9 minus 8, which is 1. So the ultimate goal is to reduce 256 over here, and we have to do it in steps. 16 squared is 256, and 4 squared is 16, and those exponents multiply whatever exponential expressions we have over here until we get our bases the same. Once our bases are the same, we go ahead and set our exponential powers equal to each other and solve for x. We're going to go ahead and do one more. So if I have 1 over 8 raised to the x divided by 2 minus 1 equals 1/4 raised to the x divided by 3 power. Okay, so let's think about this for a second. So we want our bases, our fractions, to be the same. We want the bases, our fractions here, to be the same. Now, obviously 1 and 1 are the same, but 8 and 4 are not the same. Some of you guys might start to think, okay, if we want really our denominators to be the same, which will make our fractions to be the same, well, I can just multiply 4 times 2 and get 8. Well, we're dealing with exponential powers, so we have to think exponentially. So 4 to the first gives me 4. 4 to the second does not give me 8. That is 16, right? So I'm just thinking, okay, 4 to the first is 4. 4 to the second is actually 16 and not 8. Well, let's think about 8 for a second. 8 to the first gives me 8. So I just can't multiply 4 times 2 and get 8. 4 squared is 16. So obviously, I'm going to have to do something to my 8s as well to get them to match. So let's see here. 8 squared, we have to think exponentially here. 8 squared is 64. I wonder if maybe we can take our 4 and cube it. 4 cubed is 4 times 4, which is 16, and then times 4 again. So 16 times 4 is actually 64. So if I actually cube the 4, I'm going to get 64. And if I were to square the 8, I would also get 64. So that is the strategy that I'm going to use. So I'm going to actually cube this fraction here, the 1/4, and I would actually square the fraction here, and that's going to give me the 64. Now, some of you guys might be wondering, how does that work? Okay, so I'm going to show you. If I had r over t squared, that is the same as r squared over t squared. Okay, and so we're going to use this strategy here. So I'm going to square this fraction here, and I'm going to cube this fraction here. And when I do that, I just want to show you real quick, 1 squared over 8 squared gives me 1 over 64. And then over here, 1 cubed is, well, 1 cubed and then 4 cubed. 1 cubed is 1. 4 cubed is 64. So that's actually going to work. Okay, so we're going to have the same bases. So in reality, when I do that, in order to get the same base, 1 over 64, 1 over 64, I got to square our expression here, and I need to cube our expression here. And when I do that, I get 1 over 64. So really, I am multiplying this exponential expression here by 2, and then I am multiplying this exponential expression x over 3 by 3. And so with that being said, really, I have 2 times x over 2 minus 1. And over here I have 3 times x over 3. And since we know that we get the same base, we can go ahead and set them equal to each other. Okay, and so I'm going to go ahead and distribute the 2 through each term here. So I have 2 times x over 2. The 2 over 2 divides out, so I'm left with x. And then 2 times -1 is -2. And 3 over 3 will divide out. I'm left with x over here, or 1x over here. And so since we have x minus 2 equals x, I will go ahead and subtract this x on both sides. These cancel out. All my x's here cancel out. I have -2 equals 0. So this is actually no solution. The main key point to this problem is to realize, okay, if I square the fraction, then I'm going to have to square the numerator and denominator, which gives my denominator to be 64. Over here, if I cube 1/4, I cube the numerator and the denominator. That gives me 1 over 64. So our bases match. And so I had to cube this fraction, so 3 times what we had before. And then over here, I had to square this fraction, so 2 times what we had before. And when we actually set them equal to each other, we found out that there's actually no solution for this. So that's quite interesting.